In this video, we will discuss trigonometric ratios of negative angles and compound angles and the most representative examples based on these concepts. Hello friends, welcome to my YouTube channel Number Collage. My channel features easy to understand concept videos on mathematics. I believe the best way to learn math is to understand mathematical concepts through basics. So let's learn math through basics. In this video, we will talk about what happens to the signs of trigonometric ratios when we take trigonometric ratios of negative angles. In earlier video, that is trigonometric ratios part 1, we have seen that when the initial arm OA is rotated in clockwise direction to take a new position OB, then directed angle AOB is formed. This is a negative angle because of this clockwise rotation. Let us denote this angle as minus theta. Okay. Now, in a Cartesian coordinate system, x-axis, y-axis, origin, if OA is the position of the initial arm and when it is rotated about the origin to take a final position OB, then the angle minus theta that is formed falls in the fourth quadrant, and we have seen in earlier videos that cos and sec ratios are positive in the fourth quadrant and the remaining ratios are negative. Obviously, cos of minus theta will be equal to cos theta itself. The negative sign of the angle will not affect the sign of cos ratio. But since it is a fourth quadrant, sine ratio will be negative. Therefore, sine of minus theta will be equal to minus sine theta. The negative sign of the angle has affected the sine ratio. Now, from the sign change of these two ratios, we can write the signs of negative angles of the remaining ratios. Tan of minus theta will be minus tan theta. Why? Because tan is nothing but sine upon cos, and since sine is negative, tan will also be negative. Since tan of minus theta is minus tan theta, cot of minus theta will also be minus cot theta. Since sine of minus theta is minus sine theta, cosec of minus theta, which is the reciprocal of sine theta, will also be minus cosec theta. And finally, sec of minus theta, which is also the reciprocal of cos theta, it will remain plus sec theta, just like cos theta. These are the sign changes that will happen with negative angles of trigonometric ratios. Now we will understand trigonometric ratios of compound angles. Now what are compound angles? Compound angles are addition or subtraction of two different angles such as angles A plus B or angles A minus B. So therefore we have to find the trigonometric ratios of these compound angles such as sine A plus B, sine A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B, so on and so forth. So let us see how we can find that. First, let us draw a unit circle, a Cartesian coordinate system through its center. So that this is x-axis, y-axis, origin. Since this is a unit circle, the coordinates of point P on this unit circle and on the positive x-axis will be 1, comma 0. Next, we will take point Q on this unit circle and join Q with the origin so that angle POQ is A. Therefore, coordinates of point Q will be cos A, comma sin A. Next, we will take another point R on the unit circle and join R with the origin so that angle QOR is angle B. Now, Angle POR is A plus B, therefore coordinates of point R will be cos A plus B sin A plus B. Next we will take another point S on the unit circle and join the origin with S so that angle POS becomes minus B due to clockwise rotation. Next we will join points R and point P and point S with point Q. Now we find that in triangle POR and triangle QOS, PO equals QO and OR equals OS and angle POR equals angle QOS whose magnitude is A plus B, which are compound angles. Therefore, triangle POR becomes congruent triangle QOS by SAS test of congruency, which also implies that PR equals QS, congruent parts of congruent triangles. This we can write as PR square equals QS square. Now by distance formula, PR square will be cos A plus B minus 1 whole square plus sin A plus B minus 0 whole square, that will be sin square A plus B, which equals QS square, which will be here coordinates of point S. Because of this angle minus B will be cos of minus B, but cos of minus B is cos B, comma sin of minus B. Sin of minus B will be minus sin B. So therefore QS square will be cos A minus cos B whole square plus this sin A minus this minus sin B, which will be plus sin B whole square. Now expansion of this bracket will be cos square A plus B plus 1 minus 2 cos A plus B plus sin square A plus B, that will be equal to expansion of this bracket will be cos square A plus cos square B minus 2 cos A cos B plus expansion of this bracket will be sin square A plus sin square B plus 2 sin A sin B. Now this cos square A plus B plus sin square A plus B will be 1 plus this 1 minus 2 cos A plus B, which is equal to, now cos square A plus sin square A is 1, then cos square B plus sin square B is 1 again, and we will take this minus 2 common from these two terms and write minus 2 in bracket cos A cos B minus sin A sin B. Now this 2 cancels with this 2, dividing by minus 2 on both sides. This minus 2 will cancel with this minus 2 and we will get trigonometric ratio of compound angle A plus B as cos of A plus B equals cos A cos B minus sin A sin B. So this is the trigonometric formula for compound angle A plus B. Cos A plus B equals cos A cos B minus sin A sin B. We have just found out cos A plus B equals cos A cos B minus sin A sin B. We know from the trigonometry of complementary angles sin theta equals cos 90 minus theta, which is same as cos of pi by 2 minus theta. Therefore sin A plus B will be equal to cos of pi by 2 minus A plus B. That will be cos of pi by 2 minus A minus B. We will write this as cos of pi by 2 minus A plus minus B. Now, according to this formula, this A minus B becomes A and this minus B becomes B. So, we will write this as cos A, so that will be cos of pi by 2 minus A into cos B, which will be cos of B itself, then this minus sign, then sine A, so that will be sine of pi by 2 minus A into this sine B, that will be sine of minus B multiplied by sine of minus B, but sine of minus B will be minus sine B. Now this cos of pi by 2 minus A, according to trigonometric ratios of complementary angles, it will be sine of A into this cos B minus sine of pi by 2 minus A will be cos of A multiplied by this minus sine B. Because of this minus sign will become plus. So it will be sine B, whose left hand side is sine A plus B. So therefore we get one more trigonometric ratio of compound angles, which is sine A plus B is sine A cos B plus cos A sin B. So this formula and this formula of cos A plus B are also known as addition formulae. We have cos A plus B equals cos A cos B minus sin A sin B. We have to find cos of A minus B. So we will write this cos A minus B in terms of cos A plus B. So we write cos A minus B equals cos of A plus minus B, so that this A becomes this A and this minus B becomes this B. Now we will apply this formula on this and write cos A minus B equals cos A cos minus B minus sin A sin minus B. That will be cos A. We know that cos of minus B is cos B itself minus sin A. Now we know that sin of minus B is minus sin B. So cos of A minus B will become cos A cos B minus into minus will be plus sin A sin B. So this becomes addition formula for cos A minus B, which will be cos A minus B equals cos A cos B plus sin A sin B. We have sin A plus B equals sin A cos B plus cos A sin B. With the help of this addition formula, we will find out sin A minus B. This sin A minus B in the form sin A plus B. So we write sin A plus minus B. Now we will apply this addition formula on this and write sin A minus B equals first sin A, then cos of minus B, then this plus, then cos of A, then sine of this minus B. So it will be sine A, but cos of minus B will be just cos B plus cos A, and sine of minus B will be minus sine B. So this will become sine A minus B equals sine A cos B. This plus into this minus will become minus cos A sin B. So we get addition formula for sin A minus B as sin A minus B equals sin A cos B minus cos A sin B. We have found out the four addition formulae which are very useful in solving problems on trigonometry. We will try to understand how we can remember or recall these four addition formulae in an easy way. So for that, let us try to understand the tips to remember these addition formulae. Now we will write down all the four addition formulae which we have found out. First, two addition formulae are about cos only, and there is repetition of cos cos, sin sin, cos cos, sin sin. The first term involves cos only and the second term involves sin only. When there is plus sign between A and B, there is opposite minus sign between cos A cos B and sin A sin B. When there is minus sign between A and B, there is opposite plus sign between cos A cos B and sin A sin B. The third and fourth addition formula is about sine only. And in addition formula of sine, the terms sin A cos B, cos A sin B, sin A cos B, cos A sin B are repeated, and when there is a plus sign between A and B, there is the same plus sign between sin A cos B and cos A sin B. And when there is a minus sign between A and B, there is same minus sign between sin A cos B and cos A sin B. So these are some simple tips which might be helpful in remembering and recalling these four addition formulae. Now we will see how we can solve problems on addition formulae on compound angles. In my earlier videos on trigonometric functions, we have seen how to find trigonometric values of the standard angles such as 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. But we haven't seen how to find trigonometric values of non-standard angles such as 75 degrees, 15 degrees, etc. So with the help of addition formulae on compound angles, we are able to find out trigonometric values of 75 degrees, 15 degrees, etc. Let us see how. Now, angle 75 degrees can be split into compound angles 30 degrees plus 45 degrees. So, when we want to find out sine 75 degrees, then we can write it as sine of 30 degrees plus 45 degrees and apply addition formula on these compound angles. So, we will write by addition formula of sin A plus B, sin 30 cos 45 plus cos 30 sin 45. Now cos 30 is half, cos 45 is 1 upon root 2 plus cos 30 is root 3 by 2 multiplied by sin 45 is 1 upon root 2. This will be 1 upon 2 root 2 plus root 3 upon 2 root 2. So sin 75 will be 1 plus root 3 upon 2 root 2. You can rationalize this by multiplying both numerator and denominator by root 2. That will be root 2 times 1 plus root 3 upon root 2 into root 2 is 2. 2 2s are 4. So this will be the value of sin 75. Find the value of cos pi by 12 radians. Pi by 12 radians equals pi by 12 multiplied by 180 by pi degrees. So this pi gets cancelled. 12 ones are 12 ones are 12 fives are. So that will be 15 degrees. Now cos 15 degrees will be cos of 45 minus 30 degrees. So here we can apply addition formula of cos A minus B. So that will be cos 45 cos 30 plus sin 45 sin 30. Cos 45 is 1 by root 2. Cos 30 is root 3 by 2 plus sin 45 is 1 by root 2. Sin 30 is 1 half. So that will be root 3 upon 2 root 2 plus 1 upon 2 root 2. That will be 3 plus 1 upon 2 root. For rationalizing the denominator, we will multiply both numerator and denominator by root 2. So that will be root 2 multiplied by 3 plus 1 upon root 2 into root 2 will be 2 and 2 2s are 4. So this will be the value of cos 15. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Don't forget to subscribe this channel to get more videos of this type. Give your constructive comments to make my videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.